We have this one, square roots. These are nth roots of a, okay, equal to b. What does that implies? What does this implies? Okay, we can remove these roots, this nth root here. We can remove it to generate this, and then out. We can write this one as a to power what? 1 over n. You can write that. So to now cancel this nth roots, what you're going to do is what? Is to get the inverse of this fraction, which is what? Which is n. So raise both sides of the equation to what? To power n. So if you do that, this will become a, and then b what? B to power n. So that's how we got that. Okay, that's how we got that. That's first one, and then we must note that a is greater than or equal to 0. B also is also greater than or equal to 0. Let's see some questions there. Simplify. Simplify. Look at what we have here. We have cube root of 8. That's the first one. We also have another one, cube root of minus 64. The third one, we have the fourth root of 1 over 16. Okay, and we have also another one. 6 is inside these roots, and then we have 2 to the power 6 exponent 6. Okay, and then we say that n is greater than or equal to 2 is an integer. N is an integer. Okay, n is an integer. It started from 2 and above, and it's a real number. It's a positive, it's a real number. It's an integer and it's a real number. Look at the point here. If you have a to power n, a to power n, and then you have the nth roots, very simple. If the inner power here and the one that is inside the roots, if they are the same, it's going to give you what? It's going to give you a. It's going to give you the base inside. Okay, but your n must be what? Must be even, must be odd number. Your n must be what? Must be odd number for that to happen. N must be greater than 3, greater than or equal to 3, and it must be odd number. It can be 3, it can be 5, it can be 7. So once this n here and the one at the root at this place, once they are the same, you answer be what? With the base. So for this case now, we can write this one as what? As 2 to the power 3, and then your 3 is here. So you can see this 3 here is an odd number, and it's the same with this. So it's going to give you what? It's going to give you 2. Okay. Actually, we know that cube root of 8 is what? Is 2. Okay. Let's apply for the second one. The second one is going to be equal to what? Minus. This will be 4 to the power 3. 4 to the power 3. Then the cube roots. And you can see the n here is odd number, and the same with this 3 here. So automatically it's going to give you what? It's going to give you minus 4. We're still following this rule. Number 1. Number 2. Okay, let's do this the third one here before we go to the second rules. This one, we have the 4 as the nth roots, 4 here. So this will be 1 over 2 to the power 4. And you have your 4 here. Okay. So which is the same as what? It's the same as 2 to 1 over 2 to the power 4. It's the same as that, because 1 to the power 4 is 1. Then you can put your square root and put your 4 here. Okay. So the end here is even and it's equal to this one. So it's going to be what? Absolute value of 1 over 2. And absolute value of a positive is what? Is positive. So that's 1 over 2. Okay. The second rule, if a to the power n, and we have n here, will give us what? Absolute value of a. The condition is that your n is even, and your n starts from 2 and above. N could be 2, 4, 6, 8 is an even number. Once it's even number, okay, your n is even number. The n here and the one here, once they are the same, and n is even number, it's going to give you absolute value of what? Of your base. For this one, the d part, minus 2 inside the square root, and you have 6 here. You have 6 here. So your n in this case is what? Is even. Your n is even, and it's equal to this one. Okay. So in that case, now it's going to give you what? Look at what we have here. If your n is even, it's going to give you absolute value of what? Of minus 2. And that's what? That's absolute value of minus 2 is what? Is 2. I'm applying this second rule, that second law. So that's that. Let's take one more. Let's repeat one more. Let's repeat one more. Then we'll go to the next aspect. What of another 1 over 16? We have 4 here. So this is the same thing as what? 1 over 2 to the power 4. Okay, which we can write as what? 1 over 2 to the power 4. And don't forget this one. So this will be equal to what? This is your n is even. This and these are equal. So it's going to give you what? Absolute value of what? Of a. So a is 1 over 2. And absolute value of a positive is what? Is positive. So that's that on that case. Yeah, welcome. As you're coming in, begin to type something, say something. If you are here for the first time, please subscribe to the channel. Give the videos a thumbs up. Show likes to the video. Give likes to the video. Very important. Give likes to the video. Let's make this video to go viral. Give likes to the video. Welcome. Okay, so let's continue. The first one, we have square root of 32. This will be equal to what? Actually, there is no perfect, there is no square root of 32. We're going to split into 2. That will be 16 and 2. 16 times 2, such that one of them will have a perfect square root. Okay, and that will be root what? That will be root 16 times what? Times the root 2. And then root 16 is what? It's 4. So times what? Times this. I finished that. Also, this one, there's no perfect, there's no cube root for 16. Okay, and such cases like this, you must avoid having decimal. So what we're going to do in this case is to split this one also into 2, such that one of them will have what? We have a cube root. So that will be 8 times 2. 8 times 2. Which is what? Which is equal to cube root of 8 times what? Times the remaining one, that will be cube root of what? Of 2. So cube root of this one will give us what? That will give us 2 to the power 3. And this is times what? This one has no answer. That'll be what? 2. That'll be cube root of 2. And don't forget the rule we just said. So this will be 2 times what? Times this. So that's that on that. That's that on that. Welcome, welcome, welcome to this live section. Welcome, 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 welcome. If you're new on the channel, please subscribe to the channel. Give the videos a thumbs up. Show likes. Give the videos likes. Okay, and please invite your friends. Invite your friends. I need a large number. Invite your friends to join this live section. Invite your friend to join this live section. Invite your friends, your classmates to join this live section. It's an encouragement. Invite your friends to join this live section. This is 4 here. So this one and this one, 16 could be 2 to the power 4. 81 also, that'll be 3 to the power 4. And then x to the power 5, we can split into 2 parts. One will be 4, and then another one here. Okay. Then don't forget your fourth roots. You can combine these 2 and 3 together. That'll be 2 by 3 to the power 4. And then x 4 times x. So that's what we have. Then this implies this will equal to this is 4. Excuse me. Excuse me, sorry for that. So this will be 4. This is 4. So this is even. So the n is equal. So that will be absolute value of 2 by 3, which is 2 by 3. Absolute value of positive is positive. And then this one also, that will give you one of that. And then this one will be what? Times what? Fourth root of what? Of x. And that finished that. Okay, so that's that on that case. So as you're coming in, begin to give the videos a thumbs up. So we're looking at writing expression containing fractional exponents as radicals. Okay, writing expression containing fractional exponents as radicals. Okay, the first one, the fractional power, fractional exponent we have here is 1/2. 1/2 means square roots of what? Of 4. 1/2 implies square roots of 4. So 1/2 is the square roots, and that will give us what? That will give us a 2. Same thing also here. This one will be the exponent, the power is half, which is 1/2. It's also what? Square root of what? It's also square root of what? 8. And that will be 2/2. So that's 2/2. This one, actually we can solve it in many ways. We can solve it in many ways. This will be equal to the fraction, the exponent is 1/3. The denominator of that exponent will be inside the roots. The base will be inside, will be here. So the numerator could be here, okay, or outside. So the choice is yours. And don't forget the minus with there, it's minus 27. So which implies cube root of minus 27 is minus 3 to power 1, and that's minus 3. The last one, 16. The denominator of the exponent will be here, 16 here, and then power 1, you can leave it here. Anything to power 1 is that number. There is no cube root for 16, but we can make it to be 8 and 2. 8 times 2. So make it to be 8 and 2. 8 times 2 cube roots. So which imply cube root of 8 times cube root of 2. And cube root of 8 is what? It's 2 times what? Times this. And that's finished the solution. I want you to know that we have a to power, the fraction, the fractional power, the fractional exponent. Let's say you have n over m. That's your exponent, your power. It's going to be equal to what? Square root of what? The base. The base is a. The denominator of that fraction will be here, and then the n will be here, or a. So either of the two are correct. Okay, we're going to see questions or applications of this. Okay, so that starts on this case. Let's see applications of this summary. Let's see another applications of this summary. Let's see applications of this summary. 4 to the power 3 over 2. That's 1. 4 to the power 3 over 2. The b minus 8 to the power 4 over 3. Okay. C 32 to power minus 2 over 5. So for the first one, we have this question. 4 exponent 3 over 2. That's the first one, which will be equal to what? Which will be equal to square root. If this one is 2, there's no need to put 2 inside, because this one is also what? This one is also 1 over 2. Square root is 1 over 2. So there's no need to put 2 here. Okay? So that'll be 4. And then you put your 3 here. Okay? And that will give us what? Square root of 2 is 2 to power what? To power 3, making what? Making 8. The second one, that's not the only way, but we are following the rules. Okay? We're following the rules. You can use another one. You can write this one as what? 4 is 2 to the power 2. Okay? And then times what? Times 3 over 2. So this one and this one we cancel. Then you have what? 2 to the power 3 equals what? Equals to 8. So the choice is yours. You can use this one. You can use this one. So nobody's going to tell you which particular one to use. It's left for you to decide which one you want to use. Okay? The B is going to be what? This is a fractional power. It's going to be square root. The denominator of that exponent will be here. The base will be minus 8 to power 4. Okay? And this is equal to what? This is equal to minus 2. This is equal to minus 2. You can close it to power 3. Okay? That will be equal to what? Cube root. So this one is odd, and it's the same with this. Cube root, if it's the same, it's give you what? The base, minus 2. Minus 2. Here also will be what? Will be square root of the base. The exponent is a fraction. The denominator will be here. And then you close everything to power what? Minus 2. And this is equal to 32 is 2 to the power 5. Okay? Then this one here. Once this one and this one is the same, just give us the base. Base 2 to the power what? Minus 2, which is what? This minus is 1 over 2 to the power 2, which is what? 4. Welcome. So coming in, you need to say something. Forward your question. You have your question. Forward that. So this one will be equal to what? 25. The denominator of the exponent will be here. That's 4. And then power 6. Okay. 4 power 6. So this is power 4. This is 4. Power 6. So let me check that. I think there is because there's no way except want to make this one. If this one is 6 to 5, if it's 6 to 5, then to be equal to 6 to 5 is 5 to power 4. 5 to power 4. And this is what? This is even. Is equal to this one. That'll be absolute value of what? Of 5. Which is what? Which is 5 to power 6. If I change that one to 6. So that's that on these on those question. That's that on those question. That's that on those question. Okay. But let's make it, if it's 25, if this question is 25 to power 6 over 4, let's have that question. Let's add that one. Let's have this one. Welcome to this section. Welcome. So this one is 25. 25 to power 6 over 4. 25 is the same thing as 5 to power 2. Okay, and then 6 over 4. So that will be 5 to power 2 times 6, that's 12 over 4, which is 5 to power 3. 5 to power 3, which is 125. Okay, so the rule that I apply here is this case of inner power, okay, times what? The external power. So that's what we apply, which is what? A to power mn. So that's what we apply in that case. So let's look at this one, simplifying the expression containing exponents. Okay, what we're going to do here, we have x to power simplified expression containing exponents. We have x to power 2 over 3 times y, brackets close, open and close, and then times x to power minus 2 times y, brackets open and closes to power 1 over 2. So the first thing we do first, before we apply the rules of exponents, is to open these brackets. And this half is going to affect each of the exponents, each of the power. So that will be x to power minus 2 times half to power half, and then y what? Y half. Okay? And this will be equal to what? This will be equal to, this one will be minus 1. This one times this one, that's minus 1. Then we can combine this one and this one together. When you are multiplying, and they have the same base. When you're multiplying, they have the same base. You take one of the bases, and then you add the power together. So we take one of the bases, 2 over 3 minus 1. Then this one also is having, this y is having power 1. This one is having half. So 1 plus half, that's 3 over 2. So this one will give us what? 2 over 3 minus 1. That's x to power minus 1 over 3 times what? Y 3 over 2, which will be equal to, this one will go to the bottom. So we have y 3 over 2. If you remove this minus 1 here, so to come down, and that will be x to power what? 1 over 3. Let's finish that. Let's finish that. Okay. For the second one, we're going to have this minus 3 is going to affect every content inside the bracket. It's going to affect 2. It's going to affect the x. It's going to affect y. So which will be 2 to power minus 3. And then x to power 1 over 3 times minus 3 all over y to power 2 over 3 times minus 3. Okay, so it's going to affect each of the contents. So that will be equal to this one will be 2 to the power minus 3. That will be, this minus is 1 over 2 to the power 3, which is what? Which is 1 over 8. So it will go down. So this one will also be what? 1 over 3 times minus 3. That's x to the power what? Minus 1 over 8. Okay. 2 over 3. 2 over 3 times minus 3. So that's minus 2. So y minus 2. Okay. This one also will go down. So we're going to have, and this one will go up. Don't forget that y minus 2 is 1 over y2. And there is 1 here. So when you reciprocate this one, that will be y squared over 8 what? This will come down also. So that's the answer for that one. If there is any question, put it on the comment section. I will respond to it right now. Okay. If there's any question, put it on the comment section. I will respond to it right now. Any question, put it on the comment section. I will respond to it right now. Let our finger be moving. I'm also doing that on my system. My finger is also moving. As I'm writing on the board, I'm also checking the comments. I'm also typing also. You can check the comments. Put something there. Okay. You're going to type your comments. Say something. Say something. It really encourages me. Say something. Say something. Okay. Say something and say, wow, excellent, superb, great. Okay. I appreciate your commitments. Your dedication is something. Say something, say something, say something. It's really give me an energy. It give me energy. An energy booster. Give me energy. Okay. Please call your friend to join us. We are still on. We still have a lot to discuss on these nth roots, simplifying radicals. Okay. Exponents. The next thing we want to go to now very soon is to how to rationalize. Okay, the denominator. How to rationalize the denominator. Okay, begin to type your comments. Subscribe if you are yet to do that. Subscribe. Give the videos a thumbs up. Okay, give the videos a thumbs up. Subscribe to the channel. And then x squared to power half. And then y 1 over 3 to power what? To power 1 over 2. Over. This one will become 1 over 3 and then to power 1 over 2 and then y half. So that's the first thing to do. It's going to affect each of the contents. So we're going to have this one 9 half. I said earlier on that half is square root of square root. So we have 3 for that place. 2 times 1 over 2. That's x to power 1. So this one will be y 1 over 6. 1 over 3 times 1 over 2. That's 1 over 6. Over this one 1 over 3 times 1 over 2. That's x to power 1 over 2. No, x to power 1 over 6. Okay, 1 over 3 times 1 over 2. And then y 1 over 2. So is that the final answer? No. We need to apply the rules of exponents. Okay, you are dividing, the bases are the same. You pick one of the bases and then you subtract the power. And that will be equal to 3. This one is having power 1 minus 1 minus 1 over 6. Okay. And then for the y also, y 1 over 6 minus 1 over 2. Okay. Once the bases are the same and you are dividing, okay, you just take one of the bases and you subtract the power. That's 5 over 6. That's x to power 5 over 6. x to the power 5 over 6. And then 1 over 6, 1 over 6 minus 1 over 2. Let's make this one also times 3 times 3. That's 1 over 6 minus 3 over 6. So that will give us a minus 2 over 6, which is a minus 1 over 6. Okay. Final conclusion, we have this. This minus will make the y to go down. So that's that on that question. The first one, this will be equal to minus 8 root 12. We're going to break into two parts such that one of that we have a perfect square root. So that's 4 and 3. That's 4 times 3. Okay. 4 has a perfect square root plus what? 3. Okay. And this will be equal to root 4 times what? Root 3, which is minus 8 into brackets 2 root 3. And then plus what? Root 3. So we're going to have now minus 16, 2 times minus 8. Okay. Then plus this. So once the radical, you can see the radicals are the same, root 3, root 3. Then that become addable. It become addable or subtractable. You can add or you can subtract. Once the radicals are the same, and you have 16 of this, and then plot. So what you're just doing is just the coefficient, minus 16 plus 1. So that's minus 15 to 3. So that's that. Yeah, let's say second one. So what we're going to do, 8 is 2 to the power 3. This x to the power 4 split into 2, such that one of them has a power of 3 times x. So that's this. So don't forget the cube roots. So cube root of 2 to the power 3, you can see what is here is odd number, is the same. That will give you the base, that's 2. This one also, this one and this one is the same. That will give you x. This is what? Cube root of what? Cube root of x. The second one, this will be the only thing we can do there is just the cube root of minus 1, which is that will turn that place to be what? To be minus 1. Okay. So that's what we can do there, just to find the cube root of the negative. So that's that. Then plus this one, 27 is 3 to the power 3. Don't forget the fourth here. Cube root, and then x. And that will give us, once this one is the same, the power here, the n, and the what is inside the roots are the same, to give you the what? The base. That's a plus 4 times 3. That's a 12. And then you have what? This one has no answer. X, cube root of x. So you can see cube root is here. This function is here. It's also here. So we can, here also, I didn't finish that. It's also cube root. You can factorize this. That will be equal to what? That will be equal to. And before we do that, we can add these two together. We can add this together. So that will give us we add it together. The coefficient here is 12. It's minus 1 here. So that will give us 2x. Cube root of x plus 11 times this. Okay, final conclusion, you can factorize the cube roots. You can factorize that. Okay, that will be equal to what? 2x plus 11. 2x plus 11. The first one, whenever you have a root at the denominator, okay, what you call the rational number, is going to be, we're going to use that same root to multiply the numerator and the what? And the denominator. Okay? And that will be equal to what? Root 3 over root 3 times root 3. That's root 9. That's 3. That finished that. That finished that. Okay? That finished that. The second one, we have 5 over 4 root 2. The radical here is root 2. So we're going to use it to multiply the numerator and the what? And the denominator. And that will be equal to what? 5 root 2